Hey everyone, I'm Chipalo Street. I lead the Azure IoT Edge product management team. And today we're going to give a very brief overview of what Azure IoT Edge is and then show a really cool demo of how you can deploy that using ZEDEDA technology. So the traditional IoT pattern has been for devices to create data locally and then send it to the cloud where it's processed with high value AI. And then those AI outcomes are trigger actions. These business insights often then are sent down to the device to act upon the process that that device is controlling. And the industry is finding that this initial pattern has its limitations. For example, flaky internet connections prevent devices from communicating with the cloud, sending data to mine insights, and receiving the actions that the cloud may output. Furthermore, data has gravity. The more data that a device creates locally, the less likely you are to want to send it all the way to the cloud. You probably want to process it locally on the device. And moving those insights and insight generation and actions down to the local device allows you to keep that data locally. Finally, if you need real-time responses, the round trip from going to the cloud and back down to the device may not be sufficient to respond to an event in time, especially in cases of human safety, right? Like if you want to stop a saw before it cuts through someone's arm, you want to stop it before it hits their skin, not halfway through their arm. And edge intelligence really solves these problems by moving insight extraction and action down to the local device. Furthermore, edge intelligence provides additional benefits, including protocol translation, data normalization, increased data privacy, and the ability to remove personally identifiable information on premise instead of sending that data to the cloud. So let's take a look at how one would use Azure IoT Edge to move some of this cloud intelligence down to edge devices. We'll start with an IoT workload designed for smart cameras that may run in the cloud. In this example, custom codes used to massage camera data into a format usable by some high-value AI. In this case, it's just an image recognition model created by Azure Cognitive Services. This AI produces insights which trigger an action. The first step to getting the solution to run on the edge is to containerize portions of that workload and place those containerized pieces in a container registry. You then create a workload description that describes the containers that compose this workload and target it at the right set of edge devices. After all, say you have multiple solutions, edge solutions. One is running a smart camera, one's running a smart refrigerator. Both of those solutions likely have different workloads, and you want to make sure that the right workload is running on the right type of device. So when an IoT Edge device connects to IoT Hub determines if there's any workloads appropriate for the edge device. The correct workload description is sent to the edge device, and then the edge device downloads the correct containers that compose the workload, starts the workload, and then reports the status of the workload back to the cloud. Because after all, just deploying a workload isn't enough. You really need to understand if your solution is working correctly and then take appropriate action if it's not. Once that workload is up and running, IoT Edge will continue to ensure that the workload, the AI, the actions, custom logic continues to run locally on the device, even in the event of internet failure. The runtime is also smart enough to cache data locally that was bound for the cloud, so that when the internet connection is restored, the runtime will sync data that was meant to be sent to the cloud with the cloud once that internet connection comes back. So at a very high level, Azure IoT Edge lets you create workloads, which can include high-value AI, target workloads at the right type of device, run those workloads locally in a disconnected manner, and monitor the health of those workloads from the cloud. Building an IoT workload requires expertise in many areas, and Microsoft wants to create an ecosystem that allows developers to leverage each other's skills. IoT Edge workloads are composed of modules, which are simple Docker-compatible containers, and we've created a module marketplace to foster that ecosystem. Workloads often need to collect data from devices to speak a variety of protocols. And we have folks that have been working in this area for 30 years and have experience speaking these types of devices. And this marketplace allows them to create modules that can be used by a third party creating an end-to-end solution, freeing that third party from understanding the details of data collection from the device and allowing them to really concentrate on the value that their end-to-end solution is providing. Workloads often need advanced analytics, and we're working with our Azure services to create modules which are available in the marketplace. However, there's also a set of other folks who have third-party analytics tailored for specific scenarios, and our marketplace is open to those third parties as well to sell those capabilities. Publishing a module to Marketplace is also great for our partners because it provides one place for a solution developer to go and find all the skills that they may need to create their IoT solution. And then that solution developer can augment those with scenario-specific custom business logic and deploy all of that as one workload down to an IoT Edge device. And we started building this marketplace back in July of 2018 and demoed it with some first-party modules. A few months later, we opened it up to third-party modules and provided deep integration with our developer tools so that you can create a module in VS Code and simply upload it to the marketplace from there. And in VS Code, as a solution developer, download modules from the marketplace and include it in your workload. In February of 2019, we allowed first-party modules to start billing. I believe it was Azure Stream Analytics was the first example of a first-party module that you could deploy to a device, and then the customer was charged for usage of the IP, and it leveraged the entire Azure monetization pipeline. So we took care of billing the customer, putting that into bank accounts and things like that. And that billing pipeline is a super critical piece for third parties because third parties want to monetize their IP, but they don't want to build billing infrastructure to do that. And so it's super great to announce that this year we started development of allowing third-party modules to take advantage of the Azure billing pipeline so that when you publish a module to the marketplace, you can define how much a price for usage from the end customer, and then when this module is deployed to an IoT Edge device, the runtime will track usage, send that information back to Azure, and Azure will take care of all the billing of the customer and crediting the third-party publisher's account with that money. And this will be live in 2022. At this point in the presentation, this is when I usually talk about the different types of device partners that we have who ship devices ready to use with Azure IoT Edge. But what's super cool today is we're going to talk about how you can deploy IoT Edge with ZEDEDA technology so that any device that's running ZEDEDA technology can also be an Azure IoT Edge device. So with that in mind, I'm going to hand it over to our friends over at ZEDEDA, and we'll get a live demo of this in action.
Hello, everyone. First of all, thank you, Chipalo, for a great presentation about Azure IoT. Just give me 1 minute to share my screen. I hope you all can see my screen now. Welcome to my presentation, people. Now, today in this presentation, we're going to see how we can deploy Azure IoT modules at Edge through ZEDEDA. So to do this, we will be requiring a few of the prerequisites. The first thing being Edge nodes that are onboarded to ZEDEDA Cloud Controller, and they should be online. Here, for this presentation's sake, I have onboarded 4 Edge devices in ZEDEDA Cloud Controller, and they are ready to be used. We'll be using one of these to deploy Azure modules. And then Azure IoT Edge runtime application. Here, Azure Edge runtime application is nothing but a virtual machine A runtime application is nothing but a configuration for deploying a virtual machine. So here, this runtime application is a Ubuntu based virtual machine which has IoT Edge pre-installed, and this is the runtime application that we're going to use for this presentation sake. And in this application, we can see the resources that this application is going to use from the host machine, and what are all the network rules that it is going to take up, and that's about it, and some custom config that is uh, configured. And once this its runtime application is ready, we can go for IoT modules. Even that can be found in this marketplace. We can create more and more modules that we want. Now, for this presentation's sake, I have created two modules. One is Azure's uh, simulated temperature sensor module, which is going to generate random temperature values, and it's going to send those telemetries to the event hub. And the other module that I'm going to use is this module Node-RED. Here in this module configuration, you can see the module image that we're going to download and deploy as part of this deployment. And it is completely customizable. All the modules, they are completely customizable. We can see the container options here. Here I have mapped this host port to 1880, and I have configured the routes and even the environmental variables. So all these things can be customizable, the Azure IoT modules. And to deploy them through ZEDEDA to Azure IoT. So provisioning an IoT edge device to Azure IoT Hub, it involves manually creating a Azure IoT edge device in Azure IoT Hub, and then taking the connection string and editing the configuration into the virtual machine or the IoT edge device that we're going to provision, and then restart the IoT edge daemon. And all these things are manual, right? So at ZEDEDA, we provide a fully automated flow wherein we can just simply configure which endpoint that we're going to use from Azure IoT Hub, and which application that we're going to deploy, and what all the modules that we can deploy. And as the first step, what we're going to do is provision a project to ZEDEDA. So to do that, in ZEDEDA, we go to administration and projects. Here I have created a project that I'm going to use for now. So project is a feature available in ZEDEDA for us to categorize the devices based on user requirements. For example, if a user wants to have all the devices for his own use. For example, here there are multiple projects here, and each projects have multiple devices. You can see here this VSM project. This project is my own project, and these are the devices that I'm going to use for my own use, right? So, and there are other different projects which has different devices. So based on user requirements, they can categorize the devices according to the projects. So we support two types of projects. One is regular project, and the second one is the Azure project. The regular project is what I have said, like it's a basic requirement for categorizing the devices. But this Azure project is where we configure Azure, whether the cloud policies and all the auto deployment related information. And this is going to be used when the deployed virtual machine tries to communicate to the Azure IoT Hub. So there are three set of information that is required to create this Azure project. The first one being Azure client and service details. So here I have given, we have configured this app ID. App ID is nothing but the one we create under Active Directory. There is this under Active Directory, we have app registrations. So I have created this app, and this is the information that we have given here: the application ID and its app password, and the tenant ID. Here for this deployment sake, I'm trying to provision through symmetry key. So the information that is required for this kind of provisioning is subscription ID, the device provisioning service name, the DPS group name, IoT hub name, and the resource group that it is all under. And the second policy that we're going to configure is the application policy. So under this policy, we configure which Azure runtime application that we're going to deploy. So here, like I just showed, I am using this Edge application. So this runtime application, it uses Azure IoT Edge 1.10, and uh, so that's about the application policy. The third one being module policy. This is the section where we define which modules are going to be deployed once that IoT edge device is provisioned to Azure IoT Hub. So I have created all these, I have configured everything here, and once all these client and service details sync up, only then the status of the project will be ready, because right after we create this project, we will be talking to Azure APIs, and we'll communicate and we'll validate this information. And if I give any of the information wrong, it will not be in ready state, it will be in a failed state. So there is that. So we have provisioned the project, and then this once we provision the project, we communicate to the Azure services and we validate the project. And the second step being installing the hardware. So that we have already done, which is like onboarding the device to ZEDEDA. The device will be running Eve, and through Eve we are talking to ZEDEDA's APIs, and we have provisioned that edge nodes here. Like you can see here, all the devices are ready to be used. And then third step here is to onboard the runtime edge IoT edge runtime application to Azure services. So deploying this Azure edge runtime and then provisioning itself to the Azure services and deploying the modules that we have configured in the project, everything can be done automatically through our project. So here, now that we have created all the required information for this project and it is in ready state, all we have to do is go to the devices that we want to use, select the device, select basic info, and change the project to the Azure project that we have just created and submit. So we have used the device packet Sunny Small 2. Now if we go to the Edge app instances, now that we are in the old other project, now we have to go to the Azure project that we have created. We see the packet Sunny Small device application is being just automatically deployed. We can see in the events that it has been just deployed. If you can see the time, it is just 1 minute earlier it is deployed. Now what ZEDEDA does is that it deploys this virtual machine onto the device that we have just moved it to, and once this virtual machine is up and running, we use the Azure endpoint details we have configured in the project, and we provision it to Azure IoT Hub, and then the same modules that we have configured there will be automatically deployed. So for the project's sake, I have already created a deployment here. The device name is packet Sunny Small 3, as you can see here, and this application is already onboarded to the IoT Hub endpoint that I have already configured. So if you can see here in Azure IoT Edge, the device that I already moved to this project is created here. This is the virtual machine that we have just deployed at Edge, and this virtual machine is onboarded as an IoT Edge device, and we have two modules running on top of it. Now I have already mapped this application port 1880, which I have, like I showed in Node-RED, this Edge application port of 1880 is mapped to the Edge node port as well. So I can, if the module that we have just deployed, if you want to see if it is successfully deployed, all we have to do is go to the browser, use the edge node IP with the port name, and now we see the Node-RED application is running. So all we did is create a project and move this device to this project, and everything else is automatically deployed with zero touch. Pretty cool, right? So this is how we have deployed. We just deployed Azure IoT modules at Edge through ZEDEDA, and we did not even touch a device. We did not go to the device. We did not change any configurations. Everything we did it through ZEDEDA under projects.
That's
So
awesome. And
all
like I heard you
yeah,
say that you're using in that example, you used version 1.1.0 of IoT Edge. I'm assuming that you could also use this same process to then deploy, say, the next version of IoT Edge, which is 1.2.0. And
yeah,
that's something that customers have had problems doing because IoT Edge lets you update the modules very easily, but that underlying native runtime can't be as easily updated right now unless you use something like Azure Device Update for IoT Hub. So this is another great example of how you can do device management and that
yeah,
management of the underlying host system. So it's
yeah.
really cool to see.
Thank you, thank you. So now that we have already moved this device, let's see if it is already created. So the second application that I just moved, that is also online. So in a minute or two, the modules will be deployed on this virtual machine as well, and it will also be, we can see if that device is provisioned here. In a minute or two, that will also be provisioned, and we can see that here. So that's about it. Like, we did everything through ZEDEDA and automated process. So no hustle and fuss, right? Cool. So anybody has any questions? We are good to take.
That's super cool. Thanks for demoing that.
Thank you, Chipalo. So let's wait for a minute or two. It will be onboarded, and we don't have to wait for the whole time, so for the modules to be deployed. But yeah, and pretty cool. I'll have to show this as well. So this is the application that is already running, and we can see the status of the applications through ZEDEDA. So we can see this is the IoT Edge device. I mean, this is the virtual machine that is provisioned to Azure IoT, right? So we can see the status of it, and we can view all the information straight from the Azure. All the information from Azure of this virtual machine in ZEDEDA. So we don't have to navigate to Azure IoT as well. So everything else is done here. So even for the modules, if you go here, you can see modules. And there is also other thing, like if you want to customize the modules, if you want to change the modules, we can always do that. We can go to the projects, select it, edit it, and let's say if we want to change something, the simulator sensor. So if you see here, the module, the simulated temperature sensor that is running, if we see the module identity pin, here the send interval is 5, right? So that is what we have given here. So we can always edit it. So once we edit this, we can see the changes reflecting here right away, instantly. So everything else, everything that we want to access this modules or deploy this, everything can be done. So now we can see the device that we have just moved here to this project, Sunny Small 2, the device, sorry, this application. Now this is also onboarded here. Now you can see this. Then this is the newly created application in Z Control, and that is being automatically provisioned into this project, into this IoT hub. And in a minute or two, the modules will also be deployed automatically. So right now, it is running the Edge agent, and it will bring up the Edge hub, and then it will deploy the modules that we have defined.